In Unit 8 we'll be looking at quantitative data analysis and the ways in which you can analyse the quantitative data that you might have collected. This could be from questionnaires or through other means which we discussed in the previous unit. The objectives for this session are to understand the purpose of tests of difference and tests of relationships, and to be aware of what type of data is required for tests of difference and tests of relationship. Within inferential quantitative statistics, it is normally required to have an independent and dependent variable. Variables are simply something you are measuring. Your independent variable is your cause and your dependent variable is your effect. Therefore, the independent variable represents the inputs or causes, or are tested to see if they are the cause. Whereas the dependent variable represents the output or effect, or is tested to see if it is the effect. Normally, within statistical testing, you need one dependent variable and one or more independent variables per test. Of course, within your research project, you can do numerous statistical tests, but as a starting point, normally you need at least one dependent variable and one or more independent variable. So it's important you're able to define which is your independent variable and which is your dependent variable. We've already covered the three main types of quantitative data within the session on questionnaire design, but we're going to summarise it again now, ready for discussing the statistical tests. So the first type of quantitative data is nominal data. Nominal data is distinct, mutually exclusive categories, such as male, female, or position in a team, such as manager, team leader, operator. The responses means you must be in one of the categories, but you can't be in more than one of the categories. The next type of data is ordinal rank order data, such as Likert scales or where you finished in a race, gold, silver, bronze. Now, between these different places in the scales, there is not an equal interval. So for example, between first and second in a race might be a different amount of time from between second and third, because the third place runner was further back. The third type of data is interval or ratio data, and this is a scale with equal intervals, such as time or weight. The difference between 1 and 2 kilograms is the same as the difference between 15 and 16 kilograms. It's 1 kilogram. It's important to be aware within business and management research, Likert scales and Likert type scales are often used as interval data when it comes to inputting them into statistics. And this is okay if you want to do this too within your projects. However, you should put forward some justification for doing so, such as other similar research which has treated Likert or Likert type scales in a similar way. So in this video and on this module, we're going to consider two common quantitative research designs. These are tests of difference and tests of relationship. Within statistics, there are more quantitative research designs. However, due to the size of this course, we're only going to focus on these most common two. Of course, you are able to use other statistical research designs within your research if you so wish, and you should make sure you have a good grounding in these statistical research designs before moving forward, if you're going to try and apply other designs. So first of all, tests of difference. Tests of difference determine whether there is a statistical difference between the dependent variable outcomes based on independent variable groupings. So for example, is there a difference in IQ between men and women? Or are public sector workers happier than private sector workers? Or is there a difference in chocolate consumption in EU member states? In the second example here, are public sector workers happier than private sector workers? We have the type of work, public or private, as the independent variable, and we're seeing if based on the independent variable, the dependent variable of happiness is different. In the third example, we are looking to see, is there a difference in chocolate consumption in EU member states? Our independent variable is the EU member states, and the dependent variable we're looking to see is whether there is a difference in chocolate consumption based on the independent variable of the EU member state the respondent is in. When it comes to test of difference, what you need is normally an independent variable which is either nominal or ordinal, and a dependent variable which is an interval or ratio scale. And the type of test you would normally do for tests of difference include a t-test, is used when the independent variable has two outcomes, such as public or private workplace, and an ANOVA test if the independent variable has more than two outcomes, such as EU member states, for example, France, Italy, Spain or Germany. There's more than two independent variable outcomes. We're now going to look at tests of relationships. Tests of relationships seek to find out if there is an association between one or more independent variables and the dependent variable. So for example, is salary linked to intelligence? Or does spending more money on marketing lead to higher profits? Or what impact does a healthy breakfast, good sleep, and the sense of security have on students' ability to memorise information? So in the second example, does spending more money on marketing lead to higher profits? Spending more money on marketing is our independent variable, and we're looking to see if that impacts or causes higher profits, which is our dependent variable. In the third example, what impact does a healthy breakfast, good sleep, and the sense of security have on students' ability to memorise information? We have three independent variables. We're looking to see if a healthy breakfast, good sleep, and the sense of security can impact the ability to memorise information, which is our dependent variable. And when we're looking at relationships, we normally look at correlations and regressions to see how the data plots on a graph. So on the first graph, on the left-hand side, we can see that we can plot a line between the different scores on the different axes between our independent and dependent variable. Whereas on the second graph on the right-hand side, we can see there is not a line of movement, a line of relationship between the outcomes of the independent and dependent variable on the y and x axes of the graph. So we often start off with just a simple linear regression where we're using only one independent variable. So I'm going to give you another example now of a simple linear regression using a conceptual model. So here we have an independent variable of physical attractiveness, and we're looking to see if there is a relationship between physical attractiveness and the likelihood to date. Therefore, if someone is more physically attractive, is there an increased likelihood someone's going to want to date them? And then we can add an additional variable, an additional independent variable within a multiple regression conceptual model. So here we have more than one independent variable seeking to explain the variance in the dependent variable of the likelihood to date. So if we add in perceived intelligence and physical attractiveness, we can then, through a regression model, a multiple regression model, see, first of all, do both of the independent variables, perceived intelligence and physical attractiveness, lead to an increase in likelihood to date? And if they both do lead to an increase in likelihood to date, which one is more important? Which one has the greatest explanatory power and able to predict an increase in the likelihood to date? So when it comes to tests of relationship, what do you need? Normally, both your independent variable and your dependent variable should be interval and ratio data. And this is often why people try and use Likert scales as interval or ratio data, because it allows the use of Likert scales in tests of relationship. So the types of tests you might use, first of all, is a correlation, which looks for an association between the variables. And if you find a correlation between the variables, you can then look to undertake a regression which looks to see if the independent variable can predict the dependent variable. Whilst the most common forms of tests of relationship are standard multiple regression and correlation, it is also possible to do less used methods of regression which have a binary two-option dependent variable to see if a scale can predict a binary option. And it is also possible to use it the other way round, where you have a binary independent variable looking to predict a scale, but this is less common, so we're not going to cover these in this video. However, if you are interested in doing a test like this, you should read the recommended reading. So in conclusion, it is important to know the statistical tests you want to conduct before collecting your data, as the tests will impact the type of data which is needed and the variables which should be considered. So it's essential that you start thinking ahead before collecting your data, because if you collect your data and it isn't the right data for the tests you need to answer your research questions, it can be very problematic. Also, if you are interested in conducting a piece of statistical research, I thoroughly recommend you read the reading as part of this module to ensure that you know exactly what you need and you know your way forward